Hey guys, Gautam Shenoy here, and I hope you found the previous talk quite useful. First of all, I'm sorry for not being here in person. I'm out of station today. However, I will give this 3-minute introduction by video. Thank the organizers for that. So, what I'll be talking about next week is finite Blocklength methods for various channel capacity. So, what is this? So, if you take any given channel, and if someone tells you this is the capacity, right? How do you understand it? Well, you understand this in asymptotic concept. That is, if I'm allowed to take my block lengths n larger and larger as they tend to infinity, then the achievable rate will tend to capacity, right? So that is the picture we have in the back of our heads. Now, if someone were to say, okay, that's good, well and nice. I mean, we still do analyze capacities of certain channels, but the question now is, what if somebody gives you a block length limit? Okay, suppose someone says you can only use like 10,000 samples, you can't use more than that, and then you're like, okay, well, what's the maximum achievable rate? So finite block length methods talk of how to calculate these achievable rates. Like if you are given the capacity of a channel in some form or the other, then we shall try to figure out, okay, this is the line, this is capacity, then how does the capacity curve vary as a function of n? In other words, if you restrict to block length n, then how is it going to be like? Is it going to be like this? Is it going to be like this? Like, you will ask that question. Now, why this is useful is because in finite block length, right, often it's a coding theory kind of domain. Like you're given this much block length, that's the n, and maybe message bits are k, like that. And so the question is like you're given n samples, and you want to find out what the best achievable rate is in that case. So you design a code for that. Go to design, break your head, and do something like that. But in information theory, we don't do these things. What we do is we give random coding arguments and we use some other bunch of stochastic tools. So the idea being that the average of something is less than something, then at least one item is less than that, so there you have it like that. So those kind of inferences we will see, but we will go a bit into detection estimation theory and certain results from there, which are useful, which are surprisingly useful to get very good bounds on finite block length bounds. And we will, and while we cannot exactly tell you exactly C of n, we will try to the capacity as a function of n. We will try to we'll give bounds like upper bound as well as a lower bound on this quantity, and these bounds will be pretty tight. Like they will probably vary like order of log n or something. So I guess I will see you next on March 14. So yeah, and have a great day, guys, and happy Valentine's Day.